Hi, everybody. Welcome back to our series on AP Computer Science. Today, I want to do something that I used to kind of wait till a little bit later in the course to do, but I just feel like with everything going on, this is just going to fit right in everybody's wheelhouse, maybe even clear up some things. And so then I want to move on to some more interesting aspects, if you will, of object oriented programming. But I want to just make sure that we have a way to review what we've done so far. So I've made a project, and I'd like you to make one as well, called Geometry. And I know you've probably done something like this before, but just one last time doing it together, maybe you'll understand something maybe a little bit better than you did in the past. What I want to explain with this project is the way that in Java we can make classes to define objects. And those classes define these objects based on states and behaviors. And these states are these variables that they have. And at its most basic level, an object has to be defined in some way by primitive data that's written directly to the computer. But we can also define our objects to have other objects. So, for example, I could make a student object that has a book object, that has a page object, that has a word object. So you can see that things can get more and more complicated in that way, but the object-oriented programming handles it all, keeps everything neatly compartmentalized. Once you've made one class work well, you can pull it in and use it as an object in another. And that's what I'd like to demonstrate with you in this lesson. And I hope that you grasp that concept of how we're growing in complexity while still keeping each individual part isolated and simple. So let's click on new class and let's make a point class. Capital P. And in geometry class, we learned that points, if we're doing two-dimensional geometry, can have an x-coordinate and a y-coordinate. So let's make this point class store information about an x and a y. That's going to perfectly define our x and y coordinates. So what should we use to define these x and y? Should they be doubles? Should they be ints? Well, I think that's a matter of choice. A lot of classes that use points that are in the Java framework restrict it to integer values because they just, each integer represents a certain pixel on the screen. So I'll tell you what, let's go ahead though and let's make them doubles. We need to make them private. Private double x, private double y. So we are going to go ahead and allow our users to plot points that are in between two values on the xy plane. But we can always convert doubles down to ints easily if we need to. So I think that's fine. Let's write our constructor. Our constructor should be public. And we're going to take in, and I'm going to share something with you right quick. I'm actually going to use the same letter value that I did earlier, x and y, because those are just really good letters. And I want to show you another way you can do this. I typically avoid this, but I can use the keyword this and say this dot x gets x, this dot y gets y. When I say this dot x, I'm indicating I want the x that was defined at the top of the class. When I need to use, I can actually use this dot x every time if I want, but I need to use it if I have a parameter the same name as my instance variable or field. So remember, this is a temporary variable x. It will go away. Java actually allows you to have variable names the same as long as they're not the same, what we call scope. So because this is a temporary x and will be deleted once I'm done with that bracket right there, it allows me to use it twice, but I have to do a this dot x so that I'm assigning that x value into that one. But I wanted to go ahead and show that to you so that you've seen it at least once. So that's a use of the word this. Okay, let's let's think about what should our point class be able to do. Well, points can't really do that much, can they? They can just exist. But we could add some functionality to it that allows our point to find the distance from itself to some other point. So let's make a public method that returns a double, and I'll say distance, how about get distance from? And it's going to take in another point, which I'll call P. So this is an unusual feature that we can do. I'm going to write this method for this point that finds the distance from this point to some other point P. Well, this point has an x value and a y value, and P has an x and a y. The way that I get P's x and y is I say P dot x, and the way that or P dot y. The way I get this point's x and y is to say this dot x, this dot y, or you can simply say x or y. So if you want the fields, or another word for instance variables, if you want the fields from the class that you're writing right now, just say their letter. If you want those same fields for another instance of this class, you have to use the variable name .x. So here's what we're going to do. We're going to say return, and we're going to call what's called a static method in the math class. And we're going to study static methods coming up very soon. But we just say the name of the class, math dot, and then it's sqrt for square root. And the distance formula is this. Let me write that. Let me put it down here for you in comments. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. That's the distance formula. I just need to code that in. So I'm going to take the x coordinate from my second point, the other point, which is the point I got in my parentheses, and I'll say p dot x minus the x coordinate of the point that I'm at right now, which is x, and I'm going to square that. Well, the way you can square it is simply multiply it times itself. Otherwise, you can say math.pow, and I'll show that at a later time. Now we're going to do the y coordinates. P dot y minus y times p dot y minus y. Okay, so that squares the difference in the y coordinates, and then I'll close it off. If you'll permit me, I don't want to beat a dead horse here, but I would like to... I think it's yelling at me about a semicolon, I think. Okay. I would like to, before we test that out, I want to make sure that you understand how this is working. So let me just copy this over here. Actually, I don't want that there anymore because it's going to be cloudy. All right, so here's the code, and we're working on a point class. So when I have a point, it has an x and a y, as we defined in our fields. But it also has methods. So this point has a method called get distance from. And this method requires that we send it a parameter. A parameter of what? Some other point. So in order to call this method, we're going to have some other point, and whatever we call that point, we're going to end up catching it in our parameter p. And that p is going to have an x, and it's going to have a y, and it's also going to have a get distance from. So I have to take this other point's x and reference it like this. And I take the x that I'm at the point that I'm coming from and I put it here. Okay? I hope that makes sense on how that works. All right. And that's what we're going to calculate. Let's give it a try. So how can we test this? Well, we're going to need to make a couple of points, right? So I am going to make a point, and I'm going to use the point 2.0 and 6.0. Now I know my Pythagorean triples, and that 3 and 4 has a distance of 5. So if I make a point with a distance of 3 to the right and 4 up, we should get a nice good distance. Otherwise it's usually a pretty yucky number. So I'm going to go 3 to the right of 2 and 4 up from 6. So I'm going to say 10.0. And let's see what we get. So now I have 2 points. If I right click on that point, I can select get distance from, and I'll type that point in there, and I get 5.0. And you'll see p.1 dot get distance from point 2. So in the code, my x and y, the just x and just y, that's the point 1's x and y. The point 2's x and y were my px and py. Let's test it for the other way. Let's call get distance from, and we'll put the other point. It shouldn't matter which order. So now we reverse it, we still get the same answer. All right, so that's the point class. X and Y are private, though. If we want to make it to where someone can actually get information about the X and Y coordinate, we should go ahead and offer getter methods for it. So let's write a couple more methods. Public double, because they're doubles, get X, and that's simply going to return the X coordinate. And public double get Y will simply return the Y coordinate. And I could now actually go back to this p.x and make that p.getx and make this x just say getx, because they're now the same, and that's just a matter of preference how you want to do that. So now when we make our point, I'll just say 5 and 7.5, I not only have the other ones, I can go ahead and get those x coordinates and get that y coordinate now using our standard accessor methods. All right, so what kind of things can points make? So I want to talk about making stuff out of other stuff, right? Well, how about a segment, right? We can make a segment out of our point class. So let's do that. How do you make a segment? You have in 2 points, right? 2 points on one endpoint and another one. Segment. So let's make it a public class, or else we can't use it, right? And in order to be a segment, we need 2 different endpoints. So I'm going to say private, keep all our variables private, but this time it's a point. Private point. Let's call it, you want to call it endpoint 1. And private point endpoint 2. Let's make our constructor that will allow people to. Now I'm going to go back to my normal way, so I don't have to use this. I certainly can if I want to, but I like to have those variable names different from the instance variables that I create. So endpoint 1 equals endpoint input 1. Endpoint 2 all right, cool. So what should our segment be able to do? Well, I hope we could describe our segment, right? Well, what's the number one characteristic about a segment? Its length, right? Let's do that. So public, it's going to be a double. Get length, the length of the segment. Well, we can go back to using our distance formula that we used from the point class, but there's no point. Huh, get it? I just have to use the methods that belong to endpoints. So, and remember, our point class has this method get distance from, right? So each one of these points have that method. So let's use them. Let's return endpoint one dot get distance from endpoint two. See how we're building up the complexity there? And we're reusing our logic. We're not reinventing the wheel here. What's another thing that segments have? Well, if you think of algebra class, they have a slope, right? So let's do a slope, which will be a double. So we can get the slope of the segment. And, you know, this is not algebra class, so no, you don't have to have this memorized, okay? I hope I'm not scaring you all, people that have fear of math out there. But it's just that math works so well for examples in computer science, and being a math teacher, I can't help it. So slope is y2 minus y1 over x2 minus x1. We could go back to the point class and we could write a method for get slope 2, but I don't know. I just don't ever see wanting to know the slope from one point to another. I would only ever want to know a slope if I had that segment in my hand. So, all right, so let's do this. We could try to do this all in one line, but we can also make temporary variables that will make our formulas a little easier to implement. And that's what I'm going to do. I'm going to say double y2. Well, y2 is going to be endpoint 2, and I want its y coordinate, right? So can I say just dot y? Well, let's see. No, y has private access and point. I don't want to be able to manipulate private variables in my other class. Remember, making variables private is a good habit, not because you're so afraid of everyone else screwing up your code, you're afraid of yourself screwing it up. No, we want to make sure that we're using our methods to control how we access it. So get y is the only way I can do it. Double y1, well, that's endpoint 1 dot get y. Let's get an x2, that'd be endpoint 2 dot get x. Let's get an x1. All right, so we've gone and we've gotten all those values, so now I can simply use my formula, and I'll say y2 minus y1 divided by x2 minus x1. And there we have it. Yeah, I could have done this all in one line, but then I would have had each one of those letters would have been that long. It would have been a pretty long formula. So I think this is a much easier way to kind of see it. All right. If we're going to have a segment, we want to make sure people can get the endpoints. So let's make some accessors for those as well. They're going to return something of type point. So I'll say get endpoint 1. All right. And there we go. I think we've got a pretty usable class here. All right, let's try it out. Let's make a couple of points. Notice that BlueJ is showing us that segment uses point. That's what this arrow is showing. It's showing that there is a point in this segment. All right, let's do 3 and 8.7. And 9.2 and 12.8. I'll do a negative 12.8. How's that? Negative 1.8. Whatever. I'm showing you that I'm not trying to be make magical values or anything like that. I'm just typing in random numbers. All right, that looks pretty good. Let's make a segment. So I'm going to make a new segment. I put that point there, and I'll put that point there, and now I got a segment. I can get my endpoints, but I already have them here. I can get the length. There's that length. And I can get the slope. And there's the slope. Pretty cool, huh? All right, I'll tell you what, let's make one more, and then we'll look at how to write a program that uses these classes, because, we don't want to have to restart on the workbench every single time, right? So we need to look at making full programs as well. All right, make a new class. This one will be our last one. Let's call it triangle. So what can I make with a triangle? What do I need to make a triangle? I need how many sides, right? I need 3. So let's do 3 segments. I'll just call this side 1. Oop, I need to type it though. What is it going to be? The side there are segments. Oh, don't plural it though. Segment. Why can't I spell? Segment side 2, private segment side 3. Am I misspelling something? Why is it mad at me? Oh, I need the word class. That's better. All right, public triangle is going to take in 3 segments. So side 1 gets S1, side 2 gets S2, side 3 gets S3. And so now we've got those stored. Well, what do you think we can have describe our triangle? How about the perimeter? How would you find the perimeter? You would take the length of all 3 sides and add them together, right? So let's do that. Return side 1 dot get length. Remember we wrote that method right here in the segment class. Get length. Let's do it. Plus side 2 dot get length plus side 3 dot get length. There we go. We've made perimeter. We could also find the area. Now this one I'm going to include just for fun, but it's a pretty much of a bear of a formula. What you do is you take the square root of the semi-perimeter, which is half the perimeter, times semi-perimeter minus side 1, or what we call A usually. If you happen to have already taken pre-cal, you would have seen this, maybe in a geometry class, but usually not. So that's the formula. It's an ugly formula, but I think it's so cool that we can do it, and it works for all triangles. I like to use it just to complete this discussion. So first, let's get the semi-perimeter. And it's nice because it gives us an opportunity to review how do you call methods that are in the class you're working in. I'm working in the triangle class, and I need to get the semi-perimeter, which is half of this triangle's perimeter. You simply say the name of the method. You don't call it on something, because if you wanted to call it on something, if you're just like, I have to call my methods on something, you could say this dot get perimeter, because it's this triangle you're calling it on. But we usually don't do that. We just say get perimeter, and I'll divide it by 2. So that's going to be S, my semi-perimeter. Okay? So now I can return math.squirt. Do you remember how to do square root? Semi-perimeter times semi-perimeter minus the first side. Side 1 dot get length. Ooh, this is going to be a long one as well. You know what? Let's do what we did last time. Let's get each one of those values. Let's say A is side 1 dot get length. So remember, side 1 is a segment in this class, but the get length method belongs to the segment. It's in the segment class. So it's in the segment class, so I have to call it on a segment, right? Get perimeter is in this class. Get length, not. It's in the segment class, so I have to call it on a segment that I have in this object. So that's, again, the difference between calling methods in the class you're working on versus calling methods in a different class. All right, we'll call B the length of side 2. And we'll call C the length of side 3. So now I can just, this is so much easier, isn't it? And close out the square root. Perfect. All right. Oh, there's one thing I don't like. Doesn't like that I can't spell, apparently. All right. Okay, let's, I got to build it up though, right? So look at that. The triangle has a segment which has a point. In fact, the segment has 2 points. The triangle has 3 segments. All right, so let's make a point. 1, 5. Let's make another point. 9, 12. Let's make a third point because we're making a triangle here. -1, 2. Oh, don't put a comma. I got to put it down here. And I know I'm typing in integers right now, but if you inspect, you will note that it does put the point zeros on them, right? Because it automatically goes up in wideness into a double. All right, let's make a segment. My first segment is going to be from point 1 to point 2. My second segment will be from point 2 to point 3. My third segment will be from point 3 to point 1. Or 1 to 3, right? The order doesn't matter. Let's make a triangle. Here comes my triangle. Click segment 1, segment 2, segment 3. Now I finally got a triangle. And it's kind of neat to see. If you inspect it, you can see the 3 sides. And if you inspect that, then you got the 2 endpoints. You inspect that, and you finally get down to that primitive. And that's what we've been talking about. We're building up in complexity. We're starting with 2 very simple values that can be written directly to the memory. We get more complicated when we talk about a point because it's got 2 of those primitive values. A segment has 2 of those points, and then a triangle has 3 of those. You can just feel the complexity grow, right? Now, let's get the area. There's the area of that triangle. Let's get the perimeter. There's the perimeter. Pretty neat, huh? How we can just build up from there. All right. I appreciate your patience, but we're going to do one more thing. We're going to make a geometry app. So let's say new class, and we're going to say geo app. All right? And we're going to practice using these things in another class. So here we go. Public geo app. And when we're writing an application, we oftentimes, sometimes we'll have windows that will pop up, or scroll bars, buttons, things like that. Whatever is that interface that we're writing the application for, and you'll get to that eventually. But for now, let's just write a single method. So public void run. Okay. And so what is it that we want this to do? Once again, I forgot the word class. All right. Let's do exactly what we just did. Let's make a point. And I'll call it point 1. How do we make an instance of the point class? We have to use the new operator. So new point, and I'll give it some values. Remember, the point class took 2 doubles for its constructor. All right, let's make another one. All right, I'm going to do 4.5 and 1.9. All right, last one. I'll make this point 9.1, and we'll go up again back to 5.5. All right, now let's make our segments. So we have to make a segment variable, segment 1 equals new segment, and we have to give it our points. So point 1, point 2. Let's make another one. Point 2 to point 3. Let's make another one. Point 3 back to point 1. Finally, we can make a triangle. And I'm going to give it segment 1, segment 2, segment 3. All right. And let's just print out some information about it to the console. System.out.println triangle.getPerimeter. system.out.println triangle dot, what else could we do? We could do get area. Let's practice how we would get the distance from one point to another from the point class. System.out.println, how would we do that? If I want to find the distance from point 1 to point 3, I have to say point 1 dot get distance from, then give it point 3. Put it in a print line statement. All right, I think that's a pretty good practice. Okay, be sure and pause the video if you didn't get that all typed in. And when we run this app, I have to make an instance of the class. Then I have to right click on it down here and select run. And there it is. If you can't see, go to view and select view show terminal. But you can see the different pieces of information about my class. All right, y'all. That is it for now. Until I see you again, take care.